Hello student, welcome to this new lecture on hyperbolic function. In this lecture, I will teach you the properties of coth hyperbolic x. Okay. In our previous lecture, we discussed the properties of tan hyperbolic x. Okay. What are the properties? Basically, the definition of tan hyperbolic x is equal to sine hyperbolic x divided by cos hyperbolic x. Okay. Remember one thing, cos hyperbolic x never zero for all value of x. Okay. Why? Because cos hyperbolic x is equal to e to the power x plus e to the power minus x by 2. This is never zero for all value of x. Okay. So the domain of tan hyperbolic x is equal to R. Okay. What is the range of tan hyperbolic x? Basically, this is of an interval -1 to 1. In our previous lecture, we discussed this in detail. Go to the previous lecture and watch the lecture. Uh, Next, tan hyperbolic x is a odd function. So tan hyperbolic of minus x is equal to minus time tan hyperbolic x, and then we find the value of tan hyperbolic x at x is equal to 0, and we get this value is equal to 0. Okay. Next, limit x tends to infinity tan hyperbolic x is equal to 1. Okay. And similarly, the limit as x tends to minus infinity tan hyperbolic x is equal to -1. And the derivative of tan hyperbolic x is equal to x square sec hyperbolic square x. Okay. Or sec hyperbolic whole square x. Okay, next, this is a strictly increasing function. This is also a one-one function, and this function is onto when the codomain is -1 to 1. Basically, if we define tan hyperbolic function from set of real number to open interval -1 to 1, then tan hyperbolic function is a onto function. In this lecture, I will teach you the basic properties and definition of coth hyperbolic x. Now, the definition basically coth hyperbolic x is equal to cos hyperbolic x divided by sine hyperbolic x. Okay, similarly, uh, we can write this as e to the power x plus e to the power minus x by 2, and sine hyperbolic x is equal to e to the power x minus e to the power minus x by 2, and we cancel 2 from both numerator and denominator. We get e to the power x plus e to the power minus x divided by e to the power x minus e to the power minus x. Okay. The hyperbolic cotangent is analogous to the trigonometric cotangent. What is the meaning? Basically, in trigonometry, we write cot x is equal to cos x divided by sin x. Similarly, here we can define cot hyperbolic x is equal to cos hyperbolic x divided by sin hyperbolic x. Okay. But it is based on exponential expression. There is the exponential expression. It is defined as the ratio of hyperbolic cosine to hyperbolic sine. Okay. Now here the cot hyperbolic x is an odd function. Why? Because cot hyperbolic minus x is equal to minus time cot hyperbolic x. We can prove this very in simple step. First take cot hyperbolic minus x is equal to put minus x in place of x. So cot hyperbolic x is equal to cos hyperbolic x divided by sin hyperbolic x. So here we can write cot hyperbolic minus x as cos hyperbolic of minus x divided by sin hyperbolic of minus x. Okay. Now cos hyperbolic of minus x is equal to cos hyperbolic x, because cos hyperbolic x is an even function, and the sine hyperbolic of minus x is equal to minus times sine hyperbolic x, because the sine hyperbolic x is an odd function. Now this can be written as like -1 into cos hyperbolic x divided by sine hyperbolic x. This can be right cot hyperbolic x. Now here we get, if we pick uh, f of x is equal to cot hyperbolic x. Okay, then here we get f of minus x is equal to minus time f of x. This is the rule for defining a function or proving a function is an odd function. So here we get f of minus x is equal to minus time f of x. So the given function f of x is equal to cot x is an odd function. Next. Now, now we find the domain of cot hyperbolic x. Okay. Note that the denominator, here is the denominator e to the power x minus e to the power minus x. Okay. It's not this is equal to 2 times sine hyperbolic x. Okay. The denominator, basically sine hyperbolic x is equal to e to the power x minus e to the power minus x by 2. So e to the power x minus e to the power minus x, this is equal to 2 times sine hyperbolic x. And the denominator is 0 when x is equal to 0. So the expression cot hyperbolic x is undefined when x is equal to 0. So this cannot be a member of domain. So we remove 0 from set of real numbers. And the other value of r other than 0, cos hyperbolic x is defined. Okay. We can find the value of cos hyperbolic x other than 0 for all value of r other than 0. So the domain of cot hyperbolic x is equal to r difference 0. Okay. So this can be written as like this infinity minus infinity upon interval minus infinity 0 union 0 infinity. We can write domain like this. Next. Next, we discuss the behavior of cot hyperbolic x as x tends to positive infinity and x tends to minus infinity. Okay, now we find limit x tends to infinity cot hyperbolic x. This is equal to limit x tends to infinity. What is cot hyperbolic x? Basically, this is e to the power x plus e to the power minus x divided by e to the power x minus e to the power minus x. Or simply, we can write this like a limit x tends to infinity. A cot hyperbolic x, we can write this as 1 by 10 hyperbolic x. Okay. Now we distribute limit x tends to infinity 1 divided by limit x tends to infinity 10 hyperbolic x. Okay. The limit of constant is equal to constant. Here the constant is 1. So limit x tends to infinity 1 is equal to 1 divided by. In our previous lecture, we discussed limit x tends to infinity 10 hyperbolic x is equal to 1. So 1 by 1 is equal to 1. Here we write 1 plus because when x tends to infinity, what hyperbolic x approaches to 1 from right hand side of 1. Okay. Look the graph. Here is the graph of cot hyperbolic x. Okay. When x tends to 0. Okay. Sorry, when x tends to infinity. When we take x as a large quantity approaches to infinity, then cot hyperbolic x, this is 1. So this graph is below the curve. Okay. Sorry. The graph is above x, above this line. Okay. This line is basically y is equal to 1. The graph of cot hyperbolic x is above the y is equal to 1 line. Okay. And y is equal to 1 line is in asymptotes. Okay. And when x tends to infinity, the graph is approaches to 1. Approaches to 1. So the limit x tends to infinity, cot hyperbolic x is equal to positive infinity. Okay. Basically, ଯେତେବେଳେ x infinity को approach करिवो, cot hyperbolic x 1 को right hand side ରୁ approach करिवो. ता माने कौन देखो ग्राफ रू? Basically देखो एटा होची 1, एटा होची y is equal to 1 line. ଆମେ ଯେତେବେଳେ କଣ କହୁଥିଲେ ଲିମିଟ ପଢିଥିଲେ this is 1. ଯଦି ଏପଟ ସାଇଡ୍ ରୁ approach କରୁଛୁ this is right hand side. ଯଦି ଏପଟ ସାଇଡ୍ ରୁ approach କରୁଛୁ this is left hand side. ତ cot hyperbolic x ଏପଟେ right hand side ରୁ 1 କୁ approach କରୁଛୁ, ଏପଟୁ 1 କୁ approach କରୁଛୁ. ଯଦି ଏପଟୁ approach କରିଥାନ୍ତା ତ 1 minus ହେଇଥାନ୍ତା. Similarly ତମେ ଏବେ ଦେଖିପାରିବ what is the limit? X tends to minus infinity cot hyperbolic x. This is minus 1. ऊपर देखो negative sign है हुआ है. Basically cot hyperbolic x approaches to minus 1 from negative side. Okay. So basically here this is the line y is equal to minus 1 and the cot hyperbolic x approaches to y is equal to minus 1 from left hand side. So the limit is 1 minus. Okay. Minus 1. Okay. Minus. This is the symbol for left hand side and right hand side. This is for left hand side. Cot hyperbolic x approaches to minus 1 from left hand side, and here the cot hyperbolic x approaches to positive 1 from right hand side when x tends to infinity. Now what is the value of what is the limiting value of cot hyperbolic x when x approaches to positive 0? Okay, x approaches to 0 from right hand side, basically not positive 0. X approaches to 0 from positive side. That means when x approaches to 0 from right hand side, what is the behavior of this function called hyperbolic x? Basically, it goes to positive infinity. Okay, and similarly, when x approaches to 0 from right, left hand side, then the graph is goes to minus infinity. This graph is look like the graph of 1 by x. The graph of 1 by x is like this. This is similar to 1 by x graph. Okay. Try to find the limit of these two things. Okay. I will give you as this homework. Now, the function has a vertical asymptotes as x is equal to 0. That means the graph cannot be uh, cross the line or intersect the line or never touches the line. Okay. And the approaches to positive infinity and negative sorry positive 1 and negative 1 as x tends to positive infinity and negative infinity. When x tends to infinity, the graph approaches to y is equal to 1 from right hand side, and when x tends to minus infinity, then the graph approaches to y is equal to minus 1 from the left hand side. Okay, these are the horizontal asymptotes. Okay, next find the value when x tends to positive infinity. Find the limiting value of cot hyperbolic x when x tends to positive infinity. X tends to infinity. We have already find this value and find this right this value and this value. These are the basic things. So I will leave it as a homework. Okay, now the monotonicity behavior of cot hyperbolic x. Basically, cot hyperbolic x is defined like this: cos hyperbolic x divided by sin hyperbolic x. And now, what is the derivative? Basically, the derivative of cot hyperbolic x is equal to minus times cosec hyperbolic square x. And since here is a negative sign, so for all x belongs to r minus 0, the derivative of cot hyperbolic x is negative. Since all value of domain, the derivative is negative, so the cot hyperbolic x is a strictly decreasing on the interval minus infinity to 0 and 0 to infinity. Okay. Now, go to the next properties. This is 1, 1 and ontoness of cot hyperbolic x. Now, since the graph is like this is strictly increasing. So by horizontal line test, we can directly say that this is a one-on function. So basically, what is horizontal line test? Uh, if a horizontal line intersect the graph at most one point, then the function is 1, 1. If a function is 1, 1, if and only if every horizontal line intersect its graph at most once. Okay. Either one time or never intersect. Then by horizontal line test, we can say that the given function f is a one-on function. If a horizontal line intersect the graph more than once, then the function is not one-on. Recall the graph of cos hyperbolic x. This is look like this. This is the graph of cos hyperbolic x. Cos hyperbolic x. By horizontal line test, we can prove this. This is not a one-one function because there exists a horizontal line which intersect the graph at 2 points. So by horizontal line test, we confirm this cos hyperbolic x is not a one-one function. Okay. So by horizontal line test, we can conclude that the coth hyperbolic function is a one-one function. Now, what about ontoness? If we define the coth hyperbolic function from r difference 0 to minus 1, so minus infinity to minus 1 union upon interval 1 to infinity, then the graph or then the function coth hyperbolic x is a onto function, because in that situation the codomain and the range of the function is equal. So if you define function like this, then in that interval the function is onto function. Okay, this is all about the properties of coth hyperbolic x. These are the summaries. Okay, this is all about today's lecture. See you soon in the next lecture. Subscribe our channel for next update. Thank you and happy learning.